So far we learned the basic idea of probability. What is the probability? Few terminologies related to that. And now let's discuss the sums. So let's start with the first question. I'm not going to start with the coin and dice. I want to start with the different questions. I want you to get the confidence that how to solve the problem. So let's start. I'm reading the question. Out of 200 bulbs in a box. Okay, so it is given total number of bulbs. How many are there? 200. Simple. Okay. In a box, 12 bulbs are defective. Okay. 12 bulbs are defective. Let's write this information. Too much information. Total number of bulbs. So, total number of bulbs is equal to 200. Done? Simple. Now what do we have? One more information. Number of defective bulbs. Let's write. So, number of defective bulbs. Defective bulbs. That is 12. Okay. One bulb is taken out at random from the box. Okay, so we are taking out one bulb randomly from the box. Simple. Now, what is the probability that the drawn bulb is not defective? Now, understand this case very interestingly. Here, we have a picture of total bulb. 200 bulbs are there. Very simple. And out of that, defective bulbs are given. That is 12. And probability that is being asked is about bulbs which are not defective. So, first of all, we need favorable outcomes. So, what is the favorable outcome? Favorable outcome is number of not defective bulb. Do we have that information? No, directly we don't have it. We have that information. We can get it. How can we get it? See over here that let's say there are 200 bulb. Yes, that's the case. Now, it is divided into two parts. First of all, defective bulbs, right? That is 12, and another is non-defective bulbs. Non-defective bulbs. So, how many can be non-defective? Simple logic, right? 200 minus 12. So, 200 minus 12 will give you 188. Simple. So, we get the number of non-defective bulbs. Right? So, what is the favorable outcome? We want to find the probability of getting non-defective bulb. That is, how many are there? 188. Good. Now, and total number of outcomes are 200. So, let's apply the formula of probability and get the answer. So, we want to get the probability of non-defective bulb. Non-defective bulb. That is, okay, favorable outcomes over, we want to get total number of outcomes. Total number of outcomes. Done? So, favorable outcomes are 188. Then, total number of outcomes are 200. I think these both are even numbers, 188 and 200. So if we do cancellation, and we'll get 50 over here and here 47. So probability is 47 by 50. This is my final answer. Now see, most of the time students, what do? They stop over here, 188 divided by 200. Your marks can cut if the number is reducible. Reducible means what? Cancelable. You can do cancellation. Remember, right? So let's recall one more time. So there are 200 bulbs and defective bulbs are given, and probability is asked about the non-defective bulb. So first of all, you need to get the favorable outcome. That is by being subtracting those two numbers. 200 minus 12 will give you 188. Simple. So we have favorable outcomes. Apply the formula. Favorable outcome divided by total outcome. So 188 divided by 200. Do the cancellation, don't go for the decimal. Fraction is sufficient. So this is how we solve the sums related to bulbs. Let's do one more question. Previously we discussed a sum related to bulbs. Now let's discuss question related to balls. You must have done this in grade 9. Just recap that. Okay. a bag contains 6 red and 5 blue balls. Okay, so there are 6 red balls. Okay, so 6 red balls and 5 blue balls. Keep noting down the information that you know as soon as you get. Don't try to digest a whole question at a time. Okay. Find the probability that the ball drawn is not red. What we want to find? We want to find the probability of not red. Now this is very logical question, right? You can get the answer within a snap as well. Nothing much to do. We do not want to get the red. Anything other than is accepted. So there are 6 red ball and 5 blue balls. First of all, let's say total number of balls. So total number of balls, that is how many? 6 and 5 will be 11. Simple. So 11 number of balls are there, or we can say total number of outcomes are what? 11. Good. Now let's talk about the favorable outcome. We do not want red, so just hide the red. Then what's left? 5 blue balls. So that's the favorable outcome. Simple. Let's get the answer. So probability of getting not red is equal to, let's say, favorable outcomes over total number of outcomes. Total number of outcomes. So favorable is what? 5 and total number of outcomes are what? 11. So this is your final answer. Remember, we cannot do any kind of simplifications over here. So that's it. Let's recall, 6 red balls are there, 5 blue balls are there, and we want to find the probability of not getting red. So here total number of outcomes are not given, right? So you add them and you get the total number of outcomes and probability of not getting red. We don't want to get the red. Anything else is accepted. So this is how you solve these sums related to balls. Let's discuss one more problem related to previous one. Little extension to the previous one. Let's start with the question. A bag contains 5 red, 8 green, 7 white balls. Okay, so again let's start with the information. We have 5 red balls. Okay, so 5 red balls, then 8 green balls. Okay, green it is. Then what's the next? 7 white balls. 7 white balls. And let's say this is a bag. Simple for understanding. Now one ball is drawn from the bag. We are taking one ball out of it. Okay, you know what is coming out. Okay, and yes, find the probability of getting not a white ball. Okay, so first we need to get probability of not white ball. Not white ball. Okay, we don't want to get the white ball, right? And second, neither green nor a red ball. Okay, so green and what do we don't want? Red as well. Okay, right. So how shall we approach? First of all, I think we should be getting the total number of balls, right? That's important step, because we have the individual number of balls but not the total one. So let's start. Total number of balls, that is 5 plus 8 plus 7, so that will be 20 number of balls, or basically 20 is the total number of outcome. Now let's move to the next step. Let's start with the first one, not white. Probability of not white. Okay, so if you don't white, if you, let's say you have red, green and white, we don't want white balls. Okay, so let's cross over it. Green, how many are green? 8. How many are red? 5. So what are accepted? Green is accepted and red is accepted, but white is not accepted. So 8 and 5 will make total 13. So how many favorable outcomes are there which is not white? That is 13. Done. And total number of outcomes we know, that is 20. So that's my first answer. First answer is done. Let's move for the second one. We do not want green and red. Okay, so probability of not green and red. Okay, green भी नहीं चाहिए and red भी नहीं चाहिए. Simple logic है. Okay, so let's do the same calculation over here. We have red, we have green, we have white. Okay, red we do not want, green we do not want. So what's left? Only white. That is 7. So favorable outcomes are 7 and total outcomes are 20. So what's my final answer? 7 over 20. Very simple. Try to understand the logic behind the question. Very easy. Not white. So other than white, all are accepted. Add the outcomes and take the total outcomes. That is 20. Second case. Not green or red either. We don't want red. We don't want green. We only want what? Whatever is left. That is white. So 7 and total number of outcomes are 20. So this was the sums related to balls and bags. Let's discuss question related to English language. Okay, you must have dealt again the same in the grade 9. Let's repeat one more time. So a letter of English alphabet is chosen at random. Okay, so it's not given that what is the total number of outcome, but we need to assume over here, right? We know already that English alphabets, there are how many? 26, right? So let's write about that. Number of alphabets. Alphabets is equal to what? 26. Done. Now what we want to do with that? Find the probability that the letter so chosen is a vowel and a consonant. So if we take one random alphabet from it, so what is the probability of getting a vowel? So let's write probability of getting vowel question mark, and next probability of getting consonant, that is question mark. Okay, then we want to find the probability of vowel. So first of all we need to get how many vowels are there in English language. So that is A, E, I, O, U. How many vowels are there? There are 5, so we can write here vowels, right, which is 5. So we want to find the probability of getting vowels, that is how many favorable outcomes are there. First of all let's talk about favorable outcomes. 1, 2, 3, 4, 5. And total number of outcomes, simple, that is 26. Done, right? Easy question. Now what about getting probability of consonant? So first of all we need to get the number of consonants. How can we get that? Yes, it's simple, right? 26 minus 5. You remove the vowel, so whatever is left is your consonant. So let's find the probability of getting consonants. That is, what is the favorable outcome? 21 and total outcome 26. So that's your probability. So probability of getting vowels is 5 over 26 and probability of getting consonants is 21 by 26. Very simple. You have vowel 5, subtract from the 26, so you get the consonant. So favorable outcome over total outcome. So probability is 21 by 26.